Good morning, students. We will continue the same chapter sound with the topic wave motion parameters. Wave motion parameter means the amplitude, time period, frequency, wave velocity, those things. So let's start with this point. See this line, propagation of wave is caused due to vibration of particles of a medium, as all we know. See here from the picture you can easily understand. This is the particle, these are the particles, and those particles are vibrating toward the right and toward the left. That means those particles are vibrating like that. Okay, so here we will say that from this mean position of the particle it will displaces up to that much. Okay, and on the other side it will displaces up to that much. So here the particles equally displace on either side of their mean position. So this will introduce the term amplitude. Amplitude is the maximum displacement of the particles on either side of their mean position. Okay, this is the maximum displacement, and this is denoted with the letter small a. Correct. Here you can see this particle is maximum displaced up to that much. Okay, so this is called amplitude. On the other side it will also displace up to that much, so it is also taken as small a. Minus sign is given here. This is only because the direction is opposite. Correct. So as the amplitude is the maximum displacement, so it can be measured with the unit of displacement, and the unit is given here meter. So unit of amplitude is meter. Now see the next point. Here we have time period. So what is the time period? See, the time period is the time taken by a particle of a medium to complete its one vibration. Okay, it is the time, like see from this picture, if the particle go up to that point and then return back to this point and then go up to that point and return back to this point, so this is called a complete vibration, one complete vibration. Okay, let me show you once again. See, if the particle is vibrating like that, this is called one vibration, and whatever the time taken for that one vibration is called the time period. So let's see the definition once again. The time taken by a particle of a medium to complete its one vibration is called the time period, which is denoted with the letter capital T. Okay, time period of the wave. As it is time period, so its unit is second. And suppose if you want to calculate the time period and we have the number of vibration, okay, which is completed, the number of vibration is completed in a given time, then if we want to calculate the time period, whatever the time taken is divided with the total number of vibration. Okay, so then we will get if we divide this, we will get one number of vibration, and whatever the time here we can calculate, that means time taken for one vibration we can call time per vibration. Correct. And this is called time period. See the next point. Here we have frequency. So what is the meaning of frequency? See, in common language we will say that how frequent the wave is. Okay, this is called the frequency of the wave. Suppose here the line you can see, the number of vibration is made by a particle of a medium in 1 second is called the frequency of the wave. It is denoted with the letters small f or small n or nu. Remember that this is not v, this is nu. Correct. So this is the definition, and one line given here, as wave propagates with each vibration and a number of vibration is made in 1 second. Okay, if the body is vibrating, if the particles are vibrating, so with each vibration a wave is propagating, one wave is propagating. So that means simply that if in 1 second, if we are considering a time 1 second, then for this 1 second a number of vibration is produced, and this number of vibration will causes the wave to be propagated. Correct. So here we can here we can add one more sentence, that frequency is the number of waves passing through a point in 1 second. So here frequency is a number of waves. Okay, this number of waves is caused by a number of vibration in 1 second, as we are considering 1 second. So 1 second, in 1 second there is a number of vibration produced, okay, and this number of vibration will causes a number of waves to be passed through a point. Okay, so frequency is the number of waves passing through a point in 1 second. See, this is how we can calculate the frequency. Frequency is equal to number of vibration per second. So we can take the number of vibration and divide with time, then after we can get whatever the frequency, correct. So suppose one frequency, suppose we are considering about one vibration, okay, one vibration takes in time t second. As we know, frequency means number of vibration divided by time. So here we have frequency is equal to one number of vibration as it is given, and the time taken for one vibration is capital T, which is the time period. So here we have a relation with f and t, that means frequency and time period. So we can directly say that frequency is equal to the reciprocal of time period, that is 1 by t, as here the number is divided with the unit second. Second is the unit of time, okay. So that means the unit of frequency is per second, second to the power minus 1, or it can also be called as hertz, hz, the symbol is hz. One thing is to be noted here, that frequency of a wave is independent of the amplitude of the wave. Initially we all understood about this amplitude, na? So the frequency of wave is independent of that amplitude, correct. It is not depending on the amplitude. Now see the next point, we have the wavelength. So what is the meaning of wavelength? First see the definition. The waves traveled a distance in each time period with the completion of one vibration. So let's understand this. Suppose one vibration is completing. So if in the completion of, with the completion of one vibration, the wave traveled a distance, okay, as one vibration is completed, so what is the time taken? As we all know, the time taken is called the time period. So in one time period, for one vibration, for the completion of one vibration, whatever the distance covered by the wave is called the wavelength. Let's see the definition. Here we have the definition. The distance traveled by a wave in one time period of vibration with the completion of one vibration of the particle of a medium is called the wavelength. It is denoted with the letter lambda. This is the symbol, this is called lambda, okay. And the SI unit of wavelength is meter, as because wavelength means the length, okay, and length is measured with the meter. Many times this wavelength is measured with some other sub units like nanometer and angstrom. Nanometer is equal to 10 to the power minus 9 meter, and angstrom is equal to 10 to the power minus 10 meter. So you can down these things, okay. Now see, one point is to be noted here, wavelength depends on the medium on which the wave is traveling, okay. Now see, the wavelength for the longitudinal wave, as we know that waves may be longitudinal or transversal, and sound wave is a longitudinal wave. So here for the sound wave, we all have studied about the compression and rarefaction. Compression means a high pressure zone, high pressure region, and rarefaction means a low pressure region. Low pressure region, that means the particle density is very less here, and here the particle density is very high. That means here particles are closely packed, here particles are away from one another, correct. So for the longitudinal wave, if you want to calculate the wavelength, or if you want to know the wavelength is actually the equal to the sum of the compression and rarefaction. So one compression and one rarefaction is equal to the wavelength, correct. So this is for the longitudinal wave. And for the transversal wave, this is the ripple produces in the water surface, that you all know, okay, we have taken the example. So here for the transverse wave, the distance between two consecutive crests, you know about crest and trough. Crest means the maximum height achieved by the surface of water while it is producing the wave, correct. So here the distance between the consecutive crests, see, from this crest to this crest, this is called the wavelength, correct, in the case of transversal wave. Now one thing is written here, displacement time graph at the below you can see, below the graph you can see distance, displacement distance graph is given here. So from this graph we can get the this one, the wavelength. Okay, here on this x-axis, sorry, on this x-axis the distance is taken, the distance up to which the wave is traveled. Okay, and this is the displacement. Displacement means uh, what will be the maximum displacement from their mean position when the particle is vibrating. So going to the next point, here we have, this is the fifth point, wave velocity. As it is a velocity, that means it is a rate at which the wave is traveling. So that means the distance traveled by a wave in 1 second is called the wave velocity or wave speed, denoted with the letter capital V. As it is a velocity or speed, so its unit is meter per second. So one thing is mentioned here, it is the rate by which the energy of wave, that is the disturbance, is transferred from one point to another, to other point, correct. So yeah, we know that when wave is propagating, it carries energy, that is in the form of disturbance. So here, how long the disturbance, that means at what rate the energy or the disturbance is transferred from one place to another place, this is given by the wave velocity, and the unit is meter per second. And one thing is given here, depends on the, yeah, that one, the that wave velocity is depends on the elasticity and the density of the medium. And one more thing, it changes when enters to any other medium, from one medium to any other medium. When it is enters, then it will changes its velocity, that means wave velocity changes. See the next point here, we have the displacement time graph. As the distance, displacement distance graph we have seen here, this one, and this one is the same kind of graph, but here on the x-axis the time is taken, you can see here at the below, time is taken, and here on the y-axis this is the displacement. Okay, this is the displacement. Now here the wave is producing like that, you can see. Okay, so if we are plotting the displacement along y-axis, then see, slowly see the particle. Okay, slowly the particles achieve its maximum position, and that's where drawing here, plotting here, slowly see, slowly this is the mean position, this line gives the equilibrium or mean position. So slowly the particle achieved to its maximum position. Okay, so after reaching its maximum position, the particle tends to back to its mean position, again it is comes back to its mean position. This line gives the equilibrium or mean position. So here whatever the maximum displacement, as we all know, is the amplitude, so it is given here, this is the amplitude, this arrow gives the amplitude, correct. Now the particle moves to another direction, so that's why here the curve is at toward the minus y, okay, toward the negative of y, negative of displacement, and after reaching to the maximum displacement, it will again come back to the mean position, as it is come back to the mean position, correct here. So here we can say one wave is completed, correct. So whatever the time taken for this one wave, one vibration, is called the time period t. T is given at the bottom, you can see, and amplitude you also can understand. So this is how we can plot the displacement time graph. Now see the next page, how we can relate the lambda, v and f, that is the wavelength, velocity and the frequency. So let's see, if the distance traveled by a wave is the wavelength, that is lambda, okay, and for the lambda, to cover that distance lambda, that means wavelength, we know that the time taken is capital T, that is the time period. Time period means whatever the time taken for one vibration, and one vibration means a distance covered of up to one wavelength, correct. See this and try to understand. Okay, I am saying this. See, wavelength means the wave traveled a distance in each time period, okay, with the completion of one vibration. So as one vibration is completed, so for that one vibration, the time period, the time is taken called time period, capital T, and then after whatever the distance covered during this time period is called the wavelength. Okay, so that's why here the distance traveled, if it is the wavelength, then we know the time taken is time period is equal to the time period capital T, and during this time period one vibration is completed. So here the wave velocity, as we know, the velocity, velocity means distance divided by time. So here the distance is the wavelength and the time is the time period. Okay, so from this relation we can directly write, see, lambda is equal to v into t. So this is given here, lambda is equal to v into t. And one more thing, as we know, here we have 1 by t. Okay, lambda into 1 by t. So this 1 by t can be replaced with frequency, as we know the relation of frequency and time period. So we can replace this 1 by t as f. So we can write this v equal to lambda into, in the place of 1 by t you can write f. So v equal to lambda into f. So this is the another relation. Okay, so here we have the relation of lambda, v and f. Correct. Here t also. Okay, now see, one numerical is solved here. The question is, a source of wave produces 40 crest and 40 trough. See, if it is 40 crest or 40 trough, then it means that there is 40 vibration. Okay, because crest and one trough gives one vibration. So it is given a 40 crest. So that means 40 crest. That means for 40 crest there will be 40 vibration. Okay, there is 40 vibration. So see, the number of vibration I have taken 40, and the time period is given here, the time, okay, the time duration is given here 0.4 seconds. So this is the total time for that much of for the production of that much of wave. Okay, so for the calculation of frequency, we know number of vibrations divided by time. So whatever the number of vibration is given here, it is 40. 40 is the number of vibration and time is given here. So if we divide those two, we can get easily 100. So 100 hertz is the frequency, and this is the answer. So I hope that all of you understood this part. Thank you.